So we are to solve for a linear system using this already provided row echelon form. This is a result of an application of row operations to a given augmented matrix that is a version of the original linear system. But since we already have this as our row echelon form, we can automatically create relationships as to values of the variables pertaining to the original linear system. As for this, we don't have specific variables, so let's try to use x sub 1, x sub 2, x sub 3, and x sub 4. So the first thing we need to do here is to probably come up with since this is already in a row echelon form, let us come up with equations that are related to this using the variables x sub 1, x sub 2, x sub 3, and x sub 4. The first row would be x sub 1 plus 0, x sub 2 is 0. So you have here 8x sub 3 minus 5x sub 4 is equal to 6. The second row would be x sub 2 plus 4x sub 3 minus 9x sub 4 equal to 3. And for the last row, I have here x sub 3 plus x sub 4 is equal to 2. Now, noticeably, we don't have a specific variable, even if you're going to look at the last row in your row echelon form or the last equation here. Two variables when added results to 2, but we don't have specific values to either x sub 3 and x sub 4. In this case, we are going to treat one of them as an arbitrary variable so that we could represent it using it in solving for the rest. This would also tell us that there are infinitely many solutions here because, again, we don't know the exact value of either x sub 3 and x sub 4. Of course, it could be 2 plus 0, 1 plus 1, negative 1 plus 3, even the fraction values. So we have infinitely many solutions. And as for that, again, let x sub 4 be an arbitrary variable, let's say t. And that is already your first representation for your x sub 4. We don't have the exact value, just an arbitrary variable. With this, we could represent this equation here as x sub 3 plus t is equal to 2. And we could solve x sub 3 in terms of t, an arbitrary variable representing x sub 4. So x sub 3 is equal to 2 minus t. And this would be our result. Again, we are using t because we don't know the exact value for x sub 4, and it could be any value. With that, let us have this next equation, and we can solve x sub 2 here. X sub 2 plus 4 x sub 3, which is 2, minus t, and then plus, minus 9 x sub 4, which is t, is equal to 3. So again, we will be using the representation of the arbitrary variable t. So you'll have here x sub 2 plus 8 minus 4t, minus 9t is equal to 3. And placing all the rest of the terms on your right hand side, you will have your result of negative 5 and then plus 13t. Negative 5 because that is 3 minus 8, and of course your negative or 13 will be moved to the other side, making it as positive 13t. Okay, and finally, with all of these representations, we could now give the representative value for x sub 1. So you have here x sub 1, you will have x sub 1 plus 8 x sub 3, which is 2 minus t, okay, and then minus 5t as your x sub 4 equal to 6. So x sub 1 plus 16, that's 16 minus 8t minus 5t is equal to 6. So x sub 1 is now 6 minus 16 is negative 10, and you'll have here negative 13t, or it will become positive 13t here as well. So these are the representations for x sub 2 and x sub 1 using the arbitrary variable representation for x sub 4, which is t. This will only happen because you have more variables, more columns, more variables here, yeah, than your rows. That would mean the excess variable is considered as, or maybe considered as, an arbitrary variable that will represent the rest of the results. So this is the solution for the specific linear system with this row echelon form. Thank you for watching.